y is inversely proportional to the square of x. I'm just going to talk about what that actually means graphically. It means that um, as I double y, I would actually have the square of x. That's not that helpful, but if we draw it on a graph, then I'd actually have to plot y against x squared, then it would look a bit like this. Um, and in theory down here as well. So how do we deal with that? Well, we can do a similar graph, but we can actually plot it against, we can plot y against 1 over x squared, and this time something different happens. We actually get a straight line, and it might be looking a bit like this. It doesn't have to be a y equals x kind of line, but any kind of straight line, and that is the starting point for this question, because we can say that y is inversely proportional to x squared, or it's proportional to 1 over x squared. That's the same thing. And from this graph, it follows then that y is equal to k over x squared, because I've instead of y equals nx plus c, it becomes sort of y equals nx because it goes through the origin. But now my x is essentially replaced by 1 over x squared, and I just use a k instead of m. So that's where this has come from. This is the key thing really to learn for this sort of question, but I've tried to explain where it's come from. Okay, now we know what happens when y is 2, x is 5, so I can substitute in. 2 is equal to k over 5 squared, and that means k is equal to 50 because 5 squared is 25. And then we're basically there. Y is equal to 50 divided by x squared, and that's our formula in this case.